So a system of equations is a set of equations with the same variables. So basically, this is telling me that instead of dealing with just one equation at a time, I'm going to deal with, for the most part, two equations at the same time. So can I ask this question? This is review. How many solutions, how many points are on one line? How many points are on one line? Yes, ma'am? Infinite number. If one equation has an infinite number of answers and the other equation has an infinite number of answers, how many do they both have together? That's the question we're going to answer, because we don't know the answer yet. You're like, wait, infinite plus infinite equals infinite. But that's actually not the case on all of these. Okay, speaking of solution, this is what you need to get down because your solutions have to be in this format. The solution to this system, is an ordered pair. And I put a little example, x comma y, so it has to be two numbers separated by a comma, the x coordinate first and the y coordinate. And I'll leave it like that, I won't. Okay, this equation has infinite number of solutions, this one has an infinite number of solutions, and together they normally have one solution, one. Out of all of them, one. And your goal is to find that one. That one ordered pair has to be a solution to both of the equations at the same time. Okay, and you're like, what's going on here? We're going to use solving by graphing to figure this out. So what we need to do is go to example number 1, and we'll start this one off. Example 1. Can somebody read the instructions on example 1? Josie? Okay, and it says by graphing, so that's the method we're going to use. There are other methods, by the way, algebraically you can do it, but we're not to that point yet. And other cool ways to solve these. But we're going to do it by graphing. Okay, write those equations down. What I want you to do is I want you to draw your coordinate plane. On your homework, I'm going to give you graph paper, but on the examples you can do it on. And I'm going to see how many of you feel that your graphs on the line paper, so your regular line paper, are pretty good. How many of you think, Mr. They're pretty good? Okay, this is going to show me if they really are or not. We're going to be able to say, yes, that's pretty good, or no, we need to work on that. Okay, I want you to go 3, let's go 4, so 8 by 8, 4 in each direction. Give yourself good spacing and make sure that they're evenly spaced, because the evenly spaced marks are going to give you a good answer. And that's why I'm going to give you graph paper on the homework, because it's really hard to do it on your own consistently, but we're going to try during this assignment, or during this lesson here. Okay. Do you guys remember yesterday? What is slope-intercept form? Does anyone remember what slope-intercept form? Okay, Emma Grace? Y equals mx plus b. And do you remember, before I start graphing, don't I have to get it in that form? So I'm looking at the first equation. Is it in the form y equals mx plus b? It's a trick question.
No.
Okay, how many of you can see that it has a slope? Can you guys see that it has a slope? And you're like, how can you tell there's a slope? Does it have the variable x in there? And does it have a number multiplying x? So I hope you guys can see that that's the slope. But does it have a y-intercept? And the answer is yes.
Plus 0.
Plus 0. Isn't that it? Can't you just put plus 0 and that doesn't change anything? So where does, and I'll underline this, where does my graph hit the y-axis? Where does it hit it? Sophie?
At 0.
at 0, right here at the origin. That's your first point. So do you guys understand, if there's no written y-intercept, then the y-intercept is going to be 0. It's right here. And I put plus 0, and that's not changing anything. Okay, can anyone show me how to use the slope to figure out my next point? Because I need another point. And in fact, I need a lot. Elizabeth? Okay, 2 over 1. So that's the slope, and that's, Jensen, your question. The whole number 2 is a fraction 2 over 1. Okay, so go ahead. How do I go? What does it mean by 2 over 1? Like to go 2 to the left, 2 down, 2 up, 2 right? I don't know. Caroline?
You do up 2 and then over 1.
Which direction?
To the right.
Okay,
Positive.
good. Up 2 over 1 to the right. That's my next point. Yes, sir?
Wait, I was going to say the other one.
Okay, give me another one.
So it's -2 over -1, so you go down 2 and to the left 1.
Okay, you can go down 2 to the left 1. And what I want you guys to do is be comfortable not only getting 3 points, but being able to get as many points as you need. I want you to cover the graph with the line. So from here, I'm going to go 2 up over 1 again. So that covers that side. I'll go 2 down over 1 this direction. And should they form a line? If your graphing of these tick marks are all good, you see how I form a line if I connect them? So go ahead and connect them. And if you did it, it's okay. I'll give you graph paper. But how many of you got that line there? Is it a positive relationship or negative relationship? Positive. Was the slope positive or negative? Does that match? Mm-hmm. Is the slope up 2 over 1 to the right, up 2 over 1 to the right, up 2 over 1 to the right, up 2 over 1 to the right? Yes. Okay. All right, we have one graph on there, but this is called a system of equations. So what else do you think I have to do on this? Like, I'm not done. I'm actually halfway there. Halfway there. What else do I do? Yep, Michael? Yeah, I'm going to graph this equation on the same coordinate plane. The same coordinate plane. Okay. Is y equals negative x plus 3 in slope-intercept form?
Yes.
Oh, yeah. Y is solved for, but what's the number in front of x?
1.
Negative 1, right? Negative 1. And then what's the y-intercept?
3.
Okay, so let me underline this, and then Sophie, go ahead.
I just have a question. For when we have our system of equations on our homework, and we have to do multiple graphs, can we do them in different colors so we don't get them mixed up?
So you have to do 2 lines on each graph. And you want to do multiple colors? I'm okay.
2 different.
Sorry, 2 colors?
Yes, sir.
That's fine. Yep. If you want to keep it straight, like this one, you can make it in pencil, and that one you can make it in red pen. I'm okay with that. Okay. Where should I start this graph right here? Where should I start it? Callie, where do you think I should start this guy?
Would you do the one, like,
Okay, you could do negative 1 over 1. That's your slope. But where do I start my graph? At the y-intercept, which is 3. Yep. You always start at that y-intercept, which is positive 3. 1, 2, 3. Right here is where I start that next graph. Okay, what's my slope? Negative 1 over 1. So where do I go from this first point? I should go, everyone, down 1 over 1 to the right.
Wait, so do we not put a point there because it's already...
Okay, so this, watch how I'm marking my paper. I go down 1 over 1. You can you just kind of darken it. Then I go down 1 over 1, down 1 over 1, and then I can go up 1 over 1, and that should be enough. Connect those with a line. All right. 2 lines intersected at 1 point. Does anyone know what that 1 point is? What's the 1 point where they both cross one another's paths? Jack?
1, 2.
At the point 1, 2. That is correct. It's right here. You guys see it? So 1, 2 is that point. Okay, how many points are on one line? Infinite. How many points are on the other line? Infinite. How many points do they share in common?
1.
And that point is?
1, 2.
That is my solution.
Oh, okay, so, okay.
That's my answer. 1, 2. Now you're like, okay, that sounds cool. I get the graphing. I got that point. But, I mean, what does it mean by 1, 2? Remember, this is the x coordinate, and that's the y coordinate. Would you agree with that? That's the x, that's the y. I can check all my answers on these types. You see this first problem? What does y equal according to that point?
2.
So 2 equals 2 times 1. Is that true or false?
True.
Check, it works. It has to be true for this equation and that equation. So what does y equal according to that point? 2. X equals. So what's negative 1 times 1? Negative 1 plus 3. Does that check? So is this point a solution for both of these? At the same time? Yes. You have solved the system of equations, the ordered pair 1, 2. See that? Question?
Yeah, I was wondering, so if you only do one, then you did it wrong, right? If it goes into one, it doesn't go into the other.
Exactly. If it could go into one, it's like, oh, it works. But then it doesn't go in the other, it's not right.
Okay.
Because any of these points, for example, will fit here, but not here necessarily. And any of these points will fit here, but not there. So check both at the same time. Okay, how many of you kind of get what we're doing here? Basically, you're graphing twice, and then you're seeing where they intersect on those graphs. Okay, page 415. I need you to try I would like you to try number 8 on page 415. Number 9, sorry. Yeah, I don't know how I got that. Number 9. And thankfully on these problems, they're all going to write them in slope-intercept form. So that's nice because you can just graph from there. So they gave you y equals x minus 8, and then y equals negative 2x minus 2.
Was
Yes,
it
ma'am?
equation for the
Slope-intercept?
Yeah.
Mm-hmm.
Does that have to be addition or?
No, it could be subtraction or a negative slope. Okay, so here is my y-intercept. By the way, does anyone know what the y-intercept is? It's not just 8, it's negative 8. Good. So negative 8 is the y-intercept. And what's the slope? I don't see any number here.
1.
Yeah, it's 1 over 1. Okay, positive 1 over 1. And then on the second equation, what's my y-intercept?
Negative 2.
Negative 2 is the y-intercept. And then what's my slope? Yep, negative 2. You mean negative 2 over 1?
Yes.
Oh my. Okay, now that they got that. Okay, when you're graphing, guys, I'm going to give you a hint. Give yourself space and plan it out before you start drawing your axes. So here, you see how my y-intercepts are both negative? So they're going to end up on the bottom portion. So I'm going to do this with my graph. I'm going to make this a little bit longer because my intercepts start at the negative version of y. Okay, so here, be neat with your points. Yeah, you can do 4. And if you need more, just extend it out. That happens. And I go 9. I mean, you don't have to. You can go 10. You can go 8. If you go 7, you're going to have to make it go longer anyway. It's just like a strategy for planning it out. Okay? All right. You can work it on your own or you can help me out. Where do I start this graph right here? Sophie?
Negative 8.
On the
X, Y.
y-axis. So 1, 2, 3, 4, 5, 6, 7, 8. There's a point right there. Okay? My slope is 1. That's not a fraction. Can I make it a fraction, Callie?
Yeah, you can go like a line and put a 1 under.
So 1 over 1. Okay, so from here I go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. And then you can draw that as a line. Notice I didn't even really go down 1 over 1 to the left. I could have, and I would have gotten a point there, but I have my line. Okay, now I want to graph the second graph. So where do I start my second graph? Caroline?
You mean your second problem? Or
Yeah, the second line. Where do I start?
and you go down to.
So on the y-axis, go down to right there. Okay, where do I go from there? So I started at -2. That's my y-intercept. But then, what's my slope? It's -2?
Go down to 1.
Over 1. Good. So I go down 2 over 1 to the right. Down 2 over 1 to the right. Down 2 over 1 to the right. And
Yeah, I'm glad we have graph paper because I completely
yeah,
divided the ones on the x-axis.
like they're a little bit different. And yeah, graph paper is going to be really nice. But remember how I asked you, how many of you think you're doing pretty good on the graphs? This is going to tell me because like if you're not intersecting at the right point, well, it's probably because our tick marks are off. But how many of you were able to find this is the intersecting point right here? And does anyone know what that point is? Josie, what's that point?
Would it be 2, 6?
Not -6. That's my solution. 2, -6. How many of you got that? Or at least if your lines were a little bit more evenly spaced, you would have got 2 negative. You can see, oh man, I made that too wide and it threw me off. Okay, any questions on how to graph? Thankfully, we have graph paper, right? I like graph paper too because it makes it really easy. Just use those grids properly. Does the solution 2, -6 fit in both of these? Okay, what does y equal according to that? Is this true? What's 1 times 2? 2 minus 8? That checks. Here, -6 equals -2. Sorry about that. -2 times 2 minus 2. What's -2 times 2? -4 minus 2? It works. It has to work in both. So out of all the infinite number of solutions for both lines, there's one ordered pair, one and only one, right here that fits both at the same time. You have solved a system of equations. Do you see how that works? Yay! You just made infinity come into control. Let me see my time, because I know we're a little bit different. Okay, I'll start with this next problem here, because there are two variations of what we're doing here. Example 3a. These are a little bit different. You're going to find out why. Okay, are these in slope-intercept form?
Yes.
Okay, good. What is the y-intercept, Sydney, of the first equation? What's the y-intercept?
3.
Positive 3. What's the slope of the first equation, Jensen? What's the slope of this equation?
1.
Yep, and you can say it's 1 over 1. Good. Okay, in the second equation, what is the y-intercept, Bella?
4.
Positive 4. Max, what's the slope of the second line?
1.
Yep, and you can call it 1 over 1. Okay, if you can identify those parts, you're in a good place to be. I think we're going to be able to graph this maybe, and then the bell will ring, I think. They both have positive intercepts, actually, so why did I do that? I need to do this. They both have positive intercepts. I'm focusing on the top, and I'm going to go, I'll just go 5 up. Oh, that's going to mess me up, I can just tell.
Oh.
Okay, how about this? Can someone graph the first line for me up here? Marissa? Hustle, sorry. No pressure, but you have 30 seconds, 10 seconds ago.
Choose Untitled. The first one?
Yeah,
Is
the
it
first
the
one.
line?
Mm-hmm.
Okay.
Give me a few points, yeah.
Oh, okay.
And then, wait just a moment.
Got it.
That's okay. Let me graph the second line, and then we'll talk. I'll leave it up here. The second line starts right here. Doesn't it go up 1 over 1 and down 1 over 1? What do you guys notice about these lines?
They're parallel.
Will they ever intersect? So after the break, we're going to talk about what happens. What's your solution?
The suspense.
Just leave our stuff here.
Yeah, just leave it right there.
I know, it feels so weird.
Goodbye, Swivl.
Mr.